Myself Dr. S.D. Balakrishnan, Professor of CSE Department. I am handling the subject Computer Networks. Today I am going to teach the topic Introduction to Computer Networks. All of us know generally what is network. When people are connected, it is also called a people network. Similarly, we can define networks in many terminology. So here we are going to discuss about network in computers. So what actually computer networks? A network is a set of nodes or devices connected by communication links. So when you are connecting two or more devices, which creates a network. So what is the advantage of creating networks? Generally, when people are connected, the people can exchange their voices. They can exchange some information. Similarly, when you want to exchange some information between the computers or any other devices, we can create a network. So a node can be a computer, or it can be a printer, or any other device capable of sending and receiving data generated by other nodes on the network. So it is we are not talking only the computers can be connected in the network, they can exchange the information. Unlike any other devices like printers, even mobile phones, many mobile phones can be connected to form a network. So a network is two or more devices connected through links. A link is a communication pathway that transfers data from one device to another. So here how you are connecting devices is very, very important. What type of connections we are going to use to connect devices? There are two possible types of connections, that is point-to-point and multi-point connections. These two are very standard connection types are available where the devices can connect to each other. So the point-to-point name itself, there is a dedicated link between two devices. That is, a point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. So these are very good techniques. The communication between two devices is so fast. Example, connection between the remote control and the television's control system. This usually happening in the households. Every households we are having television system where we can use a remote to control the televisions in the point-to-point manner. So the other type of connections, that is called a multi-point. A multi-point connection is connection in which more than two specific devices share a single link. Where what we discussed in the point-to-point connection, there is a dedicated line between two devices. Whereas when multiple devices are there, you can have a shared link. In a multi-point environment, the capacity of the channel is shared either spatially or temporally. If several devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time shared connection. So once you have the shared environment, try to understand, once you have the shared environment, the sharing can be happen based on the space where the many people can contest to access the channel. Whereas other technique is time based. When the particular user turn comes, he may communicate to the end user. So that is the second type, time shared connection. So the better understanding here I am showing the picture for point-to-point connection and the multi-point connection. Whereas you can very easily understand how the communication happen in the point-to-point connection between the station A to station B. There is a communication link where these two stations can communicate each other very directly. An alternative scenario what you are seeing there, that is multi-point connection, whereas a single shared channel, multiple devices are connected. The devices are connected to access the server, that is a mainframe server in this picture. It can be any server. So here how the stations can approach the mainframe in the shared link, that is what we discussed in the multi-point connection. It can be a time shared link or it can be a spatial shared link. That is about two types of connections, that is point-to-point connection and a multi-point connection. What benefits of networks? There are plenty, huge we can say. Few I am listing here. The following are some of the benefits of networks. It provides convenience. So computers on a network can back up their files over the network. See, generally we have standalone desktop machines in our household where you can keep your files on your hard disk. What networks permits you? You can keep your records or files somewhere else, that can be in the internet, and it allows sharing. So networked computers can share resources such as printers and disks. See, you take the organizations where they have the laboratories, there is no need of connecting printers to each devices. You can have a shared printer, many devices can make use of that. So it permits sharing. Facilitate communication. So networks facilitate the communication such as sending and receiving email, transferring files, and the video conferencing. See nowadays, the trend, the people are exchanging the information through the mail, and when they want to transfer images, videos, and when they want to have a video conferencing, they can make use of the networks. Generate savings. This is so much important. So networked computers can provide more computing power for less money. Since resources can be shared, not everyone needs their own peripherals, which can result in cost saving. This is absolutely very nice benefit of the networks, because I may have a 1 terabyte of RAM. Few people, they may adopt with very less capable RAM. When I can offer my resources to the other people through the network, that people can make use of my resources without any extra cost. Maybe the minimum cost can incur, and it provides reliability. If one part of a network is down, useful work may be still possible using a different network path. So the reliability is very good benefit of network. And simplifying scalability. It is easy to add more computers to an existing network. Let's see about network topologies. This is very important. What actually network topology? What it may be? See, people, we know what we are seeing in the real world. People are constructing the building. How they are constructing the building? Do they have any structure? Do they have any blueprint? See, straight away they are not establishing the building, right? Before that they are doing the layouts. They need to follow some layouts. What kind of layouts they must to use to build their construction, right? So network topology similarly refers to the way in which a network is laid out physically. So the topology of a network is the geometric representation of the relationship of all the links and linking devices to one another. As we know that the computers can be connected, it creates the network. But which way we must to connect? What kind of layout we must to follow? That is based on these network topologies. There are 4 basic topologies, these very important topologies: mesh topology, star topology, bus topology, and ring topology. Let us have close look to each topologies. What actually mesh, star, bus, and a ring. So these topologies are currently existing. People of us, we are enjoying the network facilities with help of these networks. What actually mesh topology? In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. So name itself, it's a dedicated connection. It's a point-to-point. You may have 10 devices in your room, in your laboratory. What happening in the mesh topology? Every device is connecting each other. That is what mesh topology. It is a dedicated point-to-point link to every other device. Example, connection of telephone regional offices, in which each regional office needs to be connected to every other regional office in order to offer services to the end users. What advantages of mesh topology? There are many advantages of mesh topology. Includes eliminate the traffic problems that can occur when links shared by multiple devices. So there is no traffic issues because I can talk to my destination directly without any third person interfering. Mesh topology is robust. It offers more privacy and security because it is not shared. Every person can talk to their destination directly. So it offers privacy and security. Point-to-point links make fault identification and fault isolation easy because When one link is failure, only the communication between those two node alone gets suffer, remaining all exist. So the disadvantages of this mesh topology: more amount of cabling and the number of IO ports required. This is very important. These are big disadvantages or drawback of this mesh topology, where if you have 10 systems, all 10 systems need 10 cable to connect remaining systems, and each should have the port to accommodate this cabling, and the hardware required to connect each link, that is IO ports and cable, can be too expensive. That is the drawback of this mesh topology. You can see, you can very easily understand what mesh topology, how the network is laid out. So each devices have point to point connection to the other devices. We have 5 devices over here. Each device is connected to the other devices. The next and important star topology, people used to prefer to implement this topology in their region, in their laboratories, in their organization, that is star topology. In a star topology, each device has a dedicated point-to-point link only to a central controller called a hub. You see what happened in the mesh topology, everyone having direct dedicated connection, but here they have the dedicated connection to the central hub instead of to the other devices. The devices are not directly linked to one another. The device is not linked directly to one another because it is connected through the central hub. A star topology does not allow direct traffic between devices. The controller acts as an exchange. So the controller central hub playing the important role. If one device wants to send data to another, it sends the data to the controller, which then relays the data to the other connected devices. So whenever a sender sends the data to the destination, instead directly connecting to the destination, it goes to the hub. Central controller, it takes the responsibility to forward the information to the destination. Example, the star topology is used in the local area networks. High-speed LANs often use a star topology with a central hub. There are advantages in this topology. A star topology is less expensive than a mesh topology, and it is very robustness, easy to install and reconfigure because the less cabling we are using in this star topology. And disadvantages: star topology is dependent on hub. If the hub goes down, the whole system is dead. That's the very big disadvantage in this star topology. When a hub goes down, the entire communication gets failed. You can see the figure of star topology where you have 4 devices connected in this with the central hub. Hub takes the responsibility to forward the packets to each other. Bus topology, the third topology, it's a very simple topology. Bus topology is multi-point connection. One long cable acts as a backbone to link all the devices in a network. Very simple, you can understand from this figure where you have one cable. The cables are stretched. It's punctured to make connection to the devices. That is called the droplet. And we can make use of a tap to connect cable with the device. So nodes are connected to the bus cable by drop lines and taps. A drop line is connection running between the device and the main cable. A tap is a connector that either splices into the main cable or punctures the shading of cable to create a contact with the metallic core. That is what I told from the above figure. You can make the puncture on the cable to connect the devices. There are advantages: ease of installation. Bus topology uses less cabling than mesh or star topologies. There are disadvantages: difficult reconnection and fault isolation. It is difficult to add new devices in the bus topology. And the last one, ring topology. In a ring topology, each device has a dedicated point-to-point connection with only 2 devices on either side of it. This is such a different network topology where it uses the ring fashion. A signal is passed along the ring in one direction from device to device until it reaches its destination. Where each device accommodates a repeater. This repeater is used to boost up the signal when the received message is not intended its own. So when a device receives a signal intended for another device, its repeater regenerates the messages and passes them along path. Example, token ring. There are advantages: easy to install and reconfigure. Fault isolation is very simplified. And disadvantages: unidirectional traffic. And the problem is when you break in the ring, disable the entire network. So very easily you can understand the devices are connected through the ring. Each device is connected with the repeater. So there are the references: data communication, the author Feroz Forosan, and computer networks, Tenenbaum. Thank you.